Welcome back, students. This is Praveen Kumar Sharma, your chemistry professor, and we were studying the chapter surface chemistry. And in the last lecture we covered some basic terms and overall concept of adsorption and some factors affecting adsorption. Now we will take adsorption isotherm. So, adsorption isotherm actually gives the extent of a gas adsorbed on the surface of a solid and pressure relation at constant temperature. That is why it is called isotherm. So, as the extent of adsorption, we take x by m, where x is the mass of gas adsorbed on the surface of adsorbent, while m is the mass of adsorbent. And we will take the relation with pressure. So, first significant isotherm we got from Freundlich, and he successfully explained the effect of pressure on the extent of adsorption approximately. So, Freundlich adsorption isotherm. As we know, if we increase the pressure, the extent of adsorption increases. So, he suggested that extent of adsorption is directly proportional to P raised to 1 by n, and on removing sign of proportionality we can use some constant, or we can write like this, where K is constant while n is also a constant. It is not constant actually, and depends upon the values of K and n depends upon the nature of adsorbate and adsorbent. Also the value of 1 by n will be less than or equal to 1, while greater than or equal to 0. So, basically the value of 1 by n is between 0 and 1, and the most probable values of 1 by n is 0.1 to 0.5. Now, how this isotherm works at different pressures. So, x by m is K. So, at very low pressure, the value of 1 by n is found to be 1. Therefore, our relation becomes x by m is equal to K P, or we can say at low pressure the extent of adsorption increases with pressure, or we get a straight line initially. At moderate pressure or intermediate pressure, the value of n is found to be less than 1, but greater than 0. So, x by m is equal to K P raised to 1 by n. So, it starts decreasing as the value of n is decreasing. So, we will get a curve and at very high pressure the value of 1 by n becomes 0. Therefore, we can write like this, or x by m is constant. So, at very high pressure the effect of pressure is nothing, and the extent of adsorption becomes constant. So, basically we got three parts in this isotherm. Initially it is directly proportional, then it is decreasing with increase in pressure, then becomes constant at high pressure. The values of K and N can be calculated with the help of by taking log of this equation and then plotting a graph between log x by m and log p. So, on taking log, we can write log k by m is equal to log x by m log k plus 1 by n log p. Now, if we draw a curve for that, so we are comparing it with straight line equation, and drawing this we will get a straight line since the slope is positive. So, we are comparing it with straight line equation, y is equal to mx plus c. So, above y is log x by m, x is log p. So, the intercept is log k and the slope which is positive is 1 by n. So, by taking this straight line graph, we can find the values of k and n easily. This adsorption isotherm given by Freundlich works well at moderate pressures, but at high pressure it is failed. Simultaneously, it is valid only for chemical adsorption in some cases. So, another adsorption isotherm was given by Langmuir. So, Langmuir's adsorption isotherm. So, his isotherm was actually based on kinetic theory of gas, and he considered that each site on the surface of adsorbent is equivalent, while the adsorption of a molecule is independent of presence of another molecule on the nearby site. So, these are the two basic as considerations used by Langmuir. He also considered that the adsorption is not the only one phenomenon which takes place at a time, and adsorption and desorption takes place simultaneously, and at equilibrium the rate of adsorption becomes equal to the rate of desorption. And he also proposed a mathematical form of his concept, which is x by m is equal to A p upon 1 plus B p. So, here A and B are the Langmuir's parameters, and their values depend upon the nature of adsorbent and adsorbate. So, if we apply it at high pressure, we can write 1 plus B p is equal to B p. Therefore, it becomes x by m is equal to A p upon B p, or we can say A upon B, and A upon B are the constants. Hence, at high pressure, pressure does not affect the extent of adsorption, while at low pressure we can write 1 plus B p is equal to 1, because p is very small. Therefore, our equation becomes x by m is equal to A p, that is, the extent of adsorption is directly proportional to pressure at low pressure. The values of A and B can be calculated as follows. On taking reciprocal of this, we will get 1 upon A p plus B p upon A p, or we can say B by A. P can be cancelled out. We got m by x is equal to A p plus B by A. Now, comparing it with straight line equation and drawing graph for m by x versus 1 by p, we will get a straight line like this, whose slope will be 1 by A, it is positive, while the intercept is B by A. So, on solving this curve, we can find the values of A and B. So, students, we can also draw these isotherms at different temperatures. So, we will get different types of curves. So, if we name them T1, T2, T3, so here the extent of adsorption is high, it means this temperature will be low. So, it can be written as this. So, as temperature increases, the extent of adsorption decreases. Now, I will take some applications of adsorption. So, the first important application is in gas masks. As you have seen gas masks with the firefighters and sometimes with the traffic police or traffic constable. So, in gas masks we use some highly adsorbent material, generally the activated charcoal, and it has the tendency to adsorb the poisonous gases from the air. Also, in coal mines, workers use these gas masks to remain unaffected from the poisonous gas. The second application is removal of color from the raw sugar. So, raw sugar is colored material, or it is colored as we use animal charcoal bed and pass that colored solution over this. So, the colored material will be adsorbed on the surface of this charcoal bed and the colorless sugar solution will be passed out. The third application is dyeing in cloths. Dyeing in cloths. As we know that cloths can absorb some colors, but sometimes these colors are not permanent and can be washed away when we wash them with soap or detergent. So, we use a moderate alum. Alum we know it is K2SO4 dot Al2SO4 thrice dot 24 H2O. This alum acts as mordant and gets adsorbed on the surface of cloth, which helps to make that color permanent. This is again example of or an application of adsorption process on industrial level. Next is for the purification of water. We use several resins for the purification of water in water treatment plants, which have some functional groups like COOH or SO3H, which adsorbs some particular ions and remove these ions from the water. So, your water becomes pure. The next application is in froth flotation process. Froth flotation process that you have studied in metallurgical processes. So, in froth flotation processes, we use to separate sulfide ore particles from unwanted impurities like silica, and we use for that pine oil and some other oil, and these pine oil droplets get adsorbed on the surface of sulfide ores and float on the surface of the solution, hence can be concentrated easily with the help of adsorption process or this application of adsorption. Next application is to create high vacuum in a particular container. Generally, vacuum is created with the help of vacuum pump, but that vacuum is not that much good. So, for that we use activated charcoal which removes even the traces of air or gases from the vessel or the container. So, it also helps in creating the high vacuum. So, these are a few applications of adsorption process. Many other applications of adsorption you study in your day to day life, and also colloids. Some colloids are also used for this. And one more important adsorption application I will give you, that is hydrogenation of oils or unsaturated fats, in which we use nickel as catalyst, and nickel we can write like this: nickel is used as catalyst, while hydrogen reacts with that unsaturated hydrocarbon to give you saturated hydrocarbon. So, during this process this hydrogen gets occluded. Occlusion is the adsorption of a gas on the metal surface. So, this hydrogen gets occluded on the surface of nickel, which helps to hydrogenase or catalyze this hydrogenation process. So, students, these are a few applications of adsorption process, and in this lecture we have covered a few adsorption isotherms like Freundlich adsorption isotherm and Langmuir's adsorption isotherm, and applications of adsorption process in our day to day life. That is all.